Hi everyone, our sum for today is here at the top of the page. It's the square root of 2x minus 1 minus 3 over the square root of 2x minus 1 is equal to negative 2. For starters, ask yourself, the ugliest part of the sum is the fact that we have a whole bunch of roots involved, but notice how this root is contained within a fraction. So to get rid of a fraction, we want to do the lowest common denominator. Okay, so we do the lowest common denominator in an equation to eventually get rid of the denominators. So the LCD would be this one here, the root of 2x minus 1, because that's the only present denominator. So what we'll do is we're going to make this the lowest common denominator for each three of the terms, 1, 2, and that side as well, 3. Now any change that you made to the original denominator, you're going to make to the respective numerators. So the first term, you had to now make the change of the denominator value. This had already the current denominator value, so no change needed to be made in the numerator. And then the negative 2 also had to be made a change with what the denominator was. In doing so, because it has the same denominator, it falls away. So we can have a therefore statement so that the numerator values are what remains in our equation. Now at this point, you can expand out because we are multiplying the square of a rooted term or rooted expression is always what's underneath it. You have made a note that the root of triangle squared is triangle. So root 2x minus 1 squared is simply 2x minus 1 less 3, and then we have the term on the right hand side. Now the ugly thing that's still here is the square root. So you want to try and isolate that. So by doing so, we carried over and simplified any of the constants and eventually divided by the coefficient. Here I did some factorizing. Now when you've isolated that root, you always aim to isolate the root, you're going to square it because the square will eliminate the root. So we do it on both sides to maintain balance in our equation, and we end up with something like this, which looks a lot better. So here you're going to do the FOIL or any form of distribution that you are familiar with. And then we can see the vague structure of a trinomial because it's an x squared, x's, and constants. So to get it into standard trinomial structure, you're going to carry everything over to one side of the equation and simplify your like terms. From here, you can use inspection to do trinomial factorization to get those two solutions set to 0. And then those two respective x values. Now, whenever you have ugly surds involved in the question, you always need to test your answer. And your test usually revolves if your right-hand side and left-hand side in the original equation will work when you substitute in these values. So when we test the solution of x is equal to 1, when you plug it in on both the left-hand side of the solution, you'll see it actually gives you the same value as what the right-hand side was. So because your LHS and your RHS are the same, this as a solution is valid. Now, when you try it with the other x value, when we plug it in on the left-hand side, the answer we get is equal to 5. When we plug in 5, the solution we get on the left is equal to positive 2. But the answer on the right-hand side is negative 2. So clearly, they are not equal. So x equal to 5 is rejected as a solution because it didn't hold that left-hand side must equal right-hand side in our test. I hope the sum made sense. If you have any questions, you're welcome to drop it below in the comment section. Please drop a like and share this with any of your friends that are in grade 11 and 12 because this was a nice challenger. Okay, see you next time.